Session here after my talk. If I could ask you, so you know now who I am, right? But I have no idea who you are. It's quite loud.
Yeah, I'm just gonna turn this down a little bit. That's maybe better.
All right. So
Yeah.
you hear me now? Yeah. These mics don't seem to like me.
Okay.
All right. So you've seen who I am, what I'm doing, what research is currently working on, and I would like to hear who are you and what's your interest, and yeah, just bump me with questions that you have.
My name is Lev. I maintain this unsupervised learning package called GenSim.
Oh, right. Yeah, sure.
And yeah, should I ask questions now, or should I just introductions?
If
Okay.
she wants to.
Yeah, so I'm Miro. I basically do business intelligence, so not really related to linguistics. I'm actually quite curious because my girlfriend studies linguistics, and this is like
Perfect
interesting
combination.
thing.
Yeah. So you're in industry. Yeah.
Yeah, my name is Steffen Wittkamp. I'm working for a customer in the area of complaint classification.
Complaint classification.
Yeah. And of course, there are some questions I am interested in.
General complaint or very specific area?
It's for travel.
Travel. Yeah. Right.
Yeah, my name is Anne Wittkamp, and I'm working for the same company as my colleague Steffen Wittkamp, and we found out that we have many use cases for the problem that text data has to be labeled manually, but you want to do it automatically, and so this is why we are here.
Right. Yeah.
Hello, my name is Susanne Momberg-Romau, and I studied print and media technology. I made my bachelor, so I already had a bit of quality assurance in this thing. And yeah, I'm about to make my master, but I don't know exactly in what, and I'm just here to listen.
Yeah, cool. All right.
My name is Matti Lyra. I'm a PhD student in natural language processing.
Right. Yeah.
So yeah, I'd like to ask, like, in this whole like deep learning approach, like, what kind of role do like people who have like more domain expertise and are more like linguists rather than like machine learning specialists, what kind of role they play in the process?
Right. It's important to have, if you have a project and can have a linguist on the team, it would be great, I would say. Because it's not that we are moving now, we are moving from the traditional feature engineering approaches to the neural net, which are presumably feature free, but there's a big but. We also need to have knowledge on what kind of features we want to get to do our deep nets, right? It's not just, we always just use word embeddings and that works, and how to combine word embeddings to represent sentences, etc. is not straightforward. But there is research right now that actually goes back and combines this dense representation with also traditional approaches. So it's not said that this is completely useless. You know, if you know what are the kind of good features for your task, you can actually quite easily beat a deep net, right? So, like, I give you just an example. A colleague of mine is working on using dictionaries as additional source in deep PyLSTM. Well, we typically don't use them, right? But you can use them in various ways. One is to combine them with feature spaces. One is to constrain the decoding. There's this information that's valuable and that has been made by linguists. And I really strongly encourage to always think at both sides. Use the novel things, use the novel techniques, look back at the history, what has people already been using, how can you actually port this to these novel methods, and then linguistic insights are very valuable. Yeah.
Okay. I have another question if no one is.
Yeah.
Okay. So another thing, I mean,
Maybe
maybe this is a stupid question, but like, what I saw, like, you highlighted the blue dot of labeled data and like extending it, right?
Yeah.
But to me, like, what seems most promising, seeing like the huge amount of unlabeled data, right, is unsupervised learning, right? So can you tell me a little bit about like the state of the art there, and like what's the status, and do you see any like anything interesting that might be happening there?
Right. Unsupervised learning, of course, inducing word embeddings is also a sort of it's always hard to really tease supervised, semi-supervised, unsupervised completely apart, right? Unsupervised learning in the early ages, like grammar induction, etc., aren't so successful. So those approaches are, completely unsupervised learning is not used that much, except for learning representations, which is kind of semi-supervised learning because you are having labels, right? It's a supervised technique that you're using then. But unsupervised, it's tricky to make it work, but I don't believe it's completely, you shouldn't give it up totally, because clustering and using classes or inducing word categories could also be a source of information that could complement linguistic resources, for instance, if you use unsupervised POS also for your model. Yeah. But at the moment, it's really, we have the machinery which mostly relies on supervised learning. We need a signal to be able to learn. We can have something called in between, like weakly supervised learning, where you say, use a system to predict the distribution, or use another, like a topic distribution, a topic model that tries to predict the distribution of the topic, and then you try to learn this as additional signal. There is things in between. I think that's the right way. But just plain from scratch, at the moment, it's not so clear how to do it successfully.
What do you mean works? When you say
yeah.
Like, when you say unsupervised learning works or doesn't work, like what do you mean?
Yeah, so I see like inducing word embeddings is a way of using unlabeled data. It's supervised learning, but it's unlabeled data, so that works very well.
But when I say it works, I put it in some classifier.
Yeah.
I usually put a classifier and see if it works or doesn't work.
So okay,
so it's like
what I mean, let's make it a bit more concrete. If you say again, go back to this BLSTM tagger, which I use a lot. If you want to have a very robust system, then take huge amounts of unlabeled data, induce embeddings, and pre-initialize your model with these embeddings. And you will see that this model then gets really soon much more robust than just trained on the original data. So that's one way of exploiting unlabeled data, which is really helpful. Just did some comparison experiments for Slovene, and then we saw that really the person there had a CRF tagger with lots of linguistic knowledge, dictionaries, etc. And just using a really huge corpus on unlabeled embeddings and this tagger with both words and character representation was getting there and was actually more robust than the traditional method. But you need to combine, in fact, you really need like word embeddings and smart pre-initialization to get this method to work in comparison and to use the right representation, right? So you need some effort to make it working. Yeah. I hope this answers your,
I can never tell if embedding works or doesn't work. Like I have to put it in a classifier in the end. It's like, you know.
Yeah.
So and then that classifier I have to train on something. So I have to use supervised learning to evaluate.
Yeah.
Supervised models.
Now
good or
that's
bad.
the
When you say that supervised learning doesn't work, I don't understand what you mean.
No, that's true, like, because that's the problem with evaluation is in fact a problem, right?
Yeah.
And especially in word embeddings and how do you evaluate then? And there is a whole workshop last year at the ECL that was about evaluating word embeddings. Sorry.
This is actually where, so at the workshop, a colleague of mine, Miroslav, was giving a talk here. He presented a paper there on his PhD work, which was precisely on this matter. Yeah. How do you evaluate these word embeddings?
You given a talk today. Like, you might have given a talk today about evaluating.
Yeah, it's not about word.
But it's still unsupervised learning, about evaluating unsupervised learning today. But it's like, you cannot say it doesn't work because if there's no metric.
No, that's true. That's true.
Just wanted, maybe there's something.
Right.
You have an opinion probably on how you evaluate them.
Well, we typically evaluate them in supervised cases, okay. And I hope people move away from like these word similarity tasks, right, which are very specific, or in general, a very important point is evaluation, and we need evaluation data, but then really try to find ways that make evaluation as robust as possible. Give you another example. So if you work on normalization, you try to normalize your text and you want to measure how good your normalization system do. But then there are test data sets that were created especially for this purpose. And even if you do then downstream evaluation like post tagging, yeah, well, you might see big improvements with you doing normalization, but then this data set is really biased towards having a lot of more normalization instances in there than you would encounter in the real world. So is this actually not overdoing it? You know, you need to take care of how you evaluate, even if you have supervised data. So the best is always to evaluate on multiple test sets, if possible, multiple tasks, if possible. But evaluation also for the cross-lingual case. How do you train? I mean, you can train parcel staggers for new languages, but if you don't have test data, how do you evaluate them? That's really a crucial aspect. So with a colleague of mine in Copenhagen, Jael Kovacic, we did for post tagging a proxy evaluation where we took dictionaries and we could see that actually trying to evaluate on the type level just by looking with softmetrics of the dictionary, that gave us kind of a proxy to the proper token level evaluation. So you could try to find ways to circumvent having completely labeled data for evaluation, but you need to have at least some way in order to compare your model to something in order to be able to, and ideally it correlates with having in-domain or in-language test data. Yeah. I hope this answers your question.
A technical question. You showed in your presentation that you had different losses, so you trained your model on different tasks. And do you have then the same network architecture in the middle?
Yeah.
Okay. And have you also seen this paper with the one model to learn them all, where they had like increases in the performance for path tree recognition, text to path tree, by training the same model also on like translation tasks? And have you applied like the similar ideas?
No, so that's a good one. I've seen the paper, I haven't really yet read it. That's on my to-do list, one model for all, right? But you can do it in different ways. So in that, what I've shown you, it's really like the hard sharing where you train a model, the same representations at the same time with 2 losses. You could also do pre-train one of the tasks and then plug it back in later on. Or there is also work now on trying to learn parameters over the tasks. So it's not like a hard sharing, you force the model to learn in the same model space, but you actually double it and see how much you trust, you know, like parameterize these layers to see how much information is shared between different tasks. There's a whole lot of things coming out in this area that are exciting to do and hopefully we'll be doing soon. But no, not yet. But for so far, mostly the hard sharing setup.
Okay,
yeah.
Thanks.
There is another paper actually, which is really on my top list. Right, is the model all you need is attention or something like that. Have you seen that? That just came out like 7 days or 10 days ago, and that's the idea is I haven't read it, so please. But the idea is really we don't need even recurrent and convolutional nets. We can do much better with feed-forward and attention mechanisms, right? So let's see. It's always getting more complicated, thinking, going back to the more simple methods. We have to see where it works. Yeah, but it's exciting. So let's see. Yeah.
Yeah. One question regarding multitask learning.
Yeah.
I have a situation where I have nested labels associated to text and which are distributed very inhomogeneously. And you said that multitask learning can help, especially to better classify these rare cases which occur. Have you tested this method, or have you tested that on data sets where you have one, or where you have a classification task with, for example, multiple labels which can occur, and tested that whether you get better results in a situation where these labels are very inhomogeneously distributed?
Right, that's a good question. So we didn't explore this direction yet that fully because the frequency binning is one way of using it, but we did analyze that, and we saw that in fact it was helping for especially these low frequent classes in that case. But of course you could try to combine if you have really a fine-grained label space and a coarse-grained label space to learn them at the same time, whether one helps, or to actually make different granularities of your label spaces, right? Because sometimes going to the really huge one with the big distribution might really hurt you. And yet you could also think about trying to put this loss at different stages in your model. So I've just shown you the traditional way of putting the auxiliary outputs at the topmost layer, but you could also have deeper models and try to predict. There's a paper also by Joaf and Anders last year CCL that tries to predict simple tasks at lower levels in the hierarchy. So you just shares. Yeah, right. You just share. Okay, the simpler task I put at the lower level, and then I don't need to make the network do the effort of learning both tasks on all levels. So you could. It's really like playing Lego these days, right? You have a toolbox. You have lots of data. You have lots of unlabeled data, but you have also labeled data from different domains or different corpora, which you can try to combine now to see that whether one helps learning the other. I so far use mainly DINAT for the tagging approaches. It's a wrapper about CNN Labs DINAT implementation. So I don't know if you guys are familiar with it. Have you heard it? No. There was a C code of neural networks from CMU, and Joaf Goldberg put the Python bindings on top of it, and that was previously called CNN, PyCNN, and now recently developed into what's called DINAT. So there's a community now developing that, and the difference to say TensorFlow or Fano is that you have this computational graph which you build up on the fly, and so you don't need to pre-compile it and have it fixed. So it's easier, like to do this hierarchical way things or combining tree-LSTM. You know, these more dynamic systems are very easy with this technique, but it's also being developed, so that it changes a lot. So it's a bit, yeah. Oh yeah, and I want to mention, there's also alternatives that you now can, I haven't had yet to look, like Chainer would be also with computational graph, dynamic computational graphs.
That's one of the packages you mentioned.
Yeah, yeah, and there is also, I think TensorFlow is also having now a dynamic library. Haven't looked at it yet. So there's more and more coming out that is interesting to look at, yeah.
As you may imagine, I have a data set of complaint messages, and usually an associated label only refers to a very small part of the document.
Aha,
yeah,
right, yeah.
What is are there possibilities to handle this problem so that my trained data is very, there's many things around that don't really fit to that label.
Yeah, because yeah, that's a tricky case, because then you.
So one idea would be to train a model on maybe which is very bad at the beginning, to train on that data set using the whole documents, feeding that in, and then use sliding windows and to evaluate on, and use this pre-existing model to find some way to improve that method in general.
Right, because ideally, if you would have a sentence level annotation, right? Yeah. This is relevant, this is not relevant. You could have a filter mechanism,
so
and yeah.
Many things which are not relevant.
Yeah. Yeah, it's you could look at the attention literature to, in fact.
How's it called?
Attention mechanisms on top.
Mm-hmm.
Yeah.
Okay. Yeah. Thank you.
Yeah. Because in fact, if you apply like a SIBO, continuous bag of words, you will average over words which have lots of them don't contribute to the task, so your final representation somewhere in the space it shouldn't be. Yeah. Yeah.
I never seen domain adaptation before your talk today, and you were mentioning the similarity metrics.
Yeah.
But when do you use them? You have a specific book and you match it to a most similar DVD? Like, I don't understand.
Yeah, so the idea there is, okay, let me phrase it, go back. Domain adaptation is actually a field that was very active 10 years ago. Okay. And there were lots of algorithms that were developed then, like structure correspondence learning, importance weighting, etc., etc. But then they were limited in the way that they were moving from one domain to the other, and you knew what was the goal to go to domain, etc. It was like one-to-one setups. So like you are only interested to go from books to DVDs, and that's all you care about. But now, since we're getting more data, we're getting more models, we want to build models that actually, how can you use this labeled data out there, right? The resources that you already have. more effectively. And if you train, so a simple, stupid baseline of domain annotation is just train on all you have together at the same time. Yeah, but as you might guess, that doesn't work very well because you're mixing very different information from different domains together. So the idea of this domain similarity matrix is, in fact, hey, let's try to find instances which look more. So you have a small set of, say, unlabeled data from your target domain, and you want to find what is the what are similar instances from this pool of data that I can use to retrain the model that is better than training on all.
So, like, if I have unlabeled Lion King the book, I want to find Lion King the DVD somehow, and
yeah,
like that's the idea, and the review and how it's labeled will be the label for my book.
Right, right, yeah,
okay.
That would be. So for that it would be the task. The label space would be the same, but you're interested in finding the instances that help you more, in order to find a way of, hey, what is this domain thing anyway, right? We typically use them by these boxes, but sometimes mixing them together is more helpful than mixing them in the right way than just training on all. Not sure if I explained it well.
Okay, so like if I find I have an unlabeled book, like about Lion King, for example, and then I want to find if it's adult or children's book, and I find a DVD which is called Lion King, and it's in the children's section, so therefore I should put my book in the children's section. Like that's kind of the is that how it works?
Yeah, you could imagine that. Or you have a new stream of data coming in, and you have a set of classifiers, or you have a set of data you can train your classifiers on. Which classifier do you want to take? That would be like the model selection part, right? Okay. Versus here, hey, I want to select the data that helps me best train this model. That's the idea.
Select the data, so I don't use all the DVD reviews, I only use some of them?
Yeah, exactly. That's the idea.
Okay, and it's similar so it's a set-to-set similarity.
Yeah, yeah.
And okay, and the metrics are usually quite unsupervised and intrinsic.
Yeah, exactly. They are intrinsic measures that don't take the labels into this, and that's why, hey, we have only so much to use, right? We use topic similarity, LDA. Okay. So you have a set of metrics, and then you have to think about what are the representations that you use on which you apply these metrics. So you could either just use the terms or the LDA or diversity measures like type token ratio, things like that. And that's the main idea here. But you need to do more in this direction.
Okay. Yeah, I think I understand it better.
But the main part of this paper that we are having now is, I did some early work on parsing. I was also interested, okay, do you have these different domains? How can I select the parsing data I trained my parser on, which is then better on some new test domain? And I only used back then topic LDA with Jensen Shen on divergence, so symmetric Kullback-Leibler divergence. And that helped the best from the space I explored, like cosine, different measures, different representations. But the question here was, can we use several metrics? And instead of just linearly combining them, learn on top of them how to weight them. And that was the idea.
Okay, so some kind of grid search, you add them together, or you multiply them, or I don't know.
Actually,
it's like average them. It's kind of like this coherence paper where you just do whatever you can to
coherence paper? I don't know that. Okay.
But it's just when they find out what's the best topic coherence to use, they just took all the possible context, all the possible ways to combine them, and just found what's the best correlates to manual annotations for a good topic or bad topic.
Right.
So it's like they just did basically a grid search. You can imagine it, but we're just trying to find a formula to combine them.
But without training them first, right? You do. You only have a small training set, the depth set that you use, but then have the whole pool of X's. How can you select the best X's for your task, given a small in-domain depth set?
And you just try one metric, then you train it, and then you see.
No, back then we just combined all of them. Actually, we didn't do the whole exploration, but since we use Bayesian optimization, we let the learner figure out what is the best combination.
I see. Oh, that's cool. Thank you.
Yeah.
So, I think there's another question. I just want to say, you said you might want to go for a talk at 11:30.
But if there are more... Yeah, okay.
It's up to you whether you want to go or not.
Okay, if nobody asks any question.
Yeah.
Do you have any you talked about new data sets which you use to improve the performance of your existing models, like the one where you had the labels which were the gaps between words in a typed in sentence. Do you have any further data sources which you want to like exploit for your models?
Right. That's a challenge, right? To come up with ideas that you could potentially use. No, I think there is more to be gained by this keystroke data. So this is only an initial investigation of if there is really signal in this. I have done some experiments and actually, but that's not surprising, how informative is this data from the individual. And that's very predictive, right? You kind of can predict who typed. So you're touching upon sensitive issues here also. At the same time, I also did some initial experiments in trying to predict demographic variables from such data. But also, I'm very interested in doing this whole computational social science aspect of trying to find out more about the person behind the text and how we can use such information, like also not just demographic variables, but like personality. I've created a data set of people who tweet about their Myers-Briggs personality type. And the idea there is, okay, it's also, again, controversial, because some people say you shouldn't use Myers-Briggs, you should go to Big Five. But my idea was, hey, people really tweet quite a lot about the types, right? Hey, I got INTJ, and I'm so happy, then they put it so. And you can get this data for free, right? It's much easier to query for these labels. And so we created a data set for Myers-Briggs type and extended that also to multiple languages. So for now, we have 7 languages with between 400 and 15,000 people with such labels, also for gender. So that's another area which is interesting to see. Because there's some initial work that shows that, say, also post taggers are sensitive to the demographics. It's not just the domain shift, but the domain shift is really something that constitutes of different factors. But we don't know what are these factors. Like, yeah.
For example, for what to work that you could convert the unsupervised data to some kind of supervised data and then have lots of data. So that was something which...
the message. But also, like in virtual case, the smart way of training these models, really. It's not just enough, you need to have a lot of data, but you need also smart ways to be able to use it, right? So that's really the idea there. Yeah.
That's the clue. Okay.
This recognizing the person behind the text. So, are there German data sets available?
So we have in our Twisty corpus, it's called. There is German Twitter data for gender and personality.
Okay.
Yeah. It's I think not the biggest data set as far as I remember.
It's free or?
Well, the data itself, you have the IDs are free. We can distribute the IDs, right? And then you can go and fetch the IDs or the data from the user.
Okay.
Yeah, there are data sets out there. There is the Koi from Copenhagen also has data sets from like Trustpilot, so review data that you can use.
Okay.
Yeah, but maybe in your case you even know something about the users themselves.
Sometimes, but of course that's a very interesting question for our customer, of course, who wants to escalate.
Exactly, and that's exactly where this. No, but honestly, this is where this field is also motivated from, right? If you have someone on the other chat box, if I can tailor the communication a little bit more to this person, it's always there's always good sides and bad sides, and that's why also I'm very happy that our field now starts an ethical discussion. So there was also this ESL workshop this year at ESL about ethics in NLP. Oh, I shouldn't move this thing. And because now we are modeling more and more the user, right? Which has advantages potentially, but also has. But my message here is really think about also labels in your case. Maybe you can gather labeled information in some distant way that you could use for your work. Yeah, you didn't ask me anything. No, last question. You asked me what you want to study. So if you're interested, I don't know, do you have a technical background a little bit or? Yeah. And you like languages? Yeah, and you like techniques, and so NLP is maybe an area to have a look at.
I can recommend that.
It's really now getting more known, right? And getting to the stage where we can find applications. So, also thanks to developers like Jensim. Yeah. Yeah, yeah. Yeah. Yeah, there's really, it's a huge field. It's like the whole, for instance, machine translation is a whole subfield in the field, right? So, text classification, parsing, there are all these different angles, and now more cogSci/psycholinguistics enters. So it's a lot of things to explore. Yeah.
Okay, well, I'll try to get you to the next talk in time.
Awesome.
Let's
thanks,
thank
Mathieu.
Barbara once again.